In this video, we're going to go over some practice problems related to the power rule and derivatives of polynomials. So first, let's start with just taking the derivatives of some kind of crazier looking functions. First of all, we have the derivative of 3 times the cubed root of x. And this is going to be similar to what we did in the first video, that we need to just rewrite this as x to some power. So note that we can write this as 3 times the derivative of something, and cubed root of x we can just write as x to the 1/3 power. So it's going to be important that we kind of know those exponent rules, that a cubed root is x to the 1/3. So therefore, our answer is going to be 3 times this derivative, which is bring the power down out in front, decrease the power by 1, so 1/3 minus 1. We have 3 times 1/3 is just 1, so this whole thing is going to be x to the negative 2/3, as the 3 and the 1/3 cancel out. All right, next one. Something else we need to keep track of is when I have ddt here instead of ddx, this means to take the derivative with respect to t instead of x. So that's the variable that I need to look for. In this case, everything is in terms of t. All right, so for this problem, I need to, first of all, write this as a sum of 2 different derivatives. So how about the derivative of 15, rewrite 1 over t to the 6 as t to the negative 6, minus the derivative of pi t to the 2/3. And we'll go one more step and we'll bring the 15 out in front. So we have the derivative of t to the negative 6. And we'll bring the pi out in front, as that's just a constant, t to the 2/3. And then we apply the power rule 2 times. This is going to be 15 times, bring the power down out in front, negative 6, t, and then decrease the power by 1. There's a negative 7. And then we have minus pi times, bring the power down out in front, 2/3, t, and decrease the power by 1, which will be negative 1/3. We'll call that our answer. We could simplify that a little bit, but I think that's fine. And then last one is kind of different form, but it's the same question. Find the derivative f prime if the function is 2x to the e minus 8. That's the exact same thing as saying the derivative of 2x to the e minus 8. So this is going to be 2 times the derivative of x to the e minus the derivative of 8. So x to the e is just going to be, e is a number, so this is going to be bring the power down out in front, decrease the power by 1. It looks a little bit weird, but that is a well-defined function. And the derivative of 8 is just a constant, so the derivative will be 0. So this whole thing is going to be 2e x to the e minus 1 power. All right, let's look at some more complicated examples dealing with this power rule. First, let's think about position and velocity and acceleration. So the position of an object in meters is given by s of t equals negative 9t cubed plus 5t squared plus 6, where t is measured in seconds. Find the velocity and acceleration of the object at time t. And what that means is I need to find the derivative and the second derivative of the function at time t. So let's start with the derivative. That's going to be equal to the derivative ddt of negative 9t cubed plus 5t squared plus 6. So we'll write that as negative 9 times the derivative of t cubed plus 5 the derivative of t squared plus the derivative of 6. Breaking it up over addition and subtraction, taking constants out in front. And this will give me a negative 9 times 3t squared plus 5 times 2t plus 0, and this will be negative 27t squared plus 10t. So then we're going to do that again. If I want to find the second derivative, that's going to be the derivative of the first derivative, which is the derivative of negative 27t squared plus 10t. So that's going to be negative 27 times the derivative of t squared plus 10 times the derivative of t. And overall, this will give me a negative 27 times 2t, the derivative of t squared, plus 10 times the derivative of t, which is 1. And overall, we get a negative 54t plus 10. And that is, in this case, the velocity and the acceleration for this problem. All right, one more problem. Find the second derivative of this function, x cubed minus 2x, and interpret its sign. So first, let's find the second derivative. Start by finding the derivative, f prime. This is going to be the derivative of x cubed minus 2x. And that's going to be the derivative of x cubed minus 2 times the derivative of x, which will give us a 3x squared minus 2. When we do the second derivative, which is what we're asked for in this problem, that's going to be the derivative of the first derivative, the derivative of 3x squared minus 2, and that will be 3 times the derivative of x squared minus the derivative of 2. So this will be 3 times 2x minus 0, or 6x total. So I've found the second derivative. Now I need to interpret its sign. So know that 6x is going to be greater than 0 when x is greater than 0. And 6x is less than 0 when x is less than 0. So that means that f is concave up. The second derivative is positive on the interval 0 to infinity. And f of x is concave down on the interval negative infinity to 0. So these are questions that we've dealt with in the previous chapter, but now we have a nice, easy way to do derivatives with this power rule, and we're going to learn even more rules in the next few sections.